Presumably, the nefarious actors out there are constantly shifting and trying to evade detection by you.
We have intelligence analysts that this is what they do, right? They research these groups, they know about sort of the latest hashtags, trends, like what emojis they're using now. If we're in a place that's inherently adversarial, then we need to make sure that this database is also robust to adversarial manipulations. Any place that you have a user that's able to upload content, there's a potential for misuse of that. Our data model basically enables us to take sort of an item, even if it's just an image, and start breaking it apart into the components that it has, so that then we can build those together into a coherent risk score.
Matar, welcome to the Super Data Science Podcast. It's awesome to have you on the show. Where are you calling in from?
I'm calling in from Israel, sunny Israel. So thanks for having me.
Sunny Israel? Is that always true? It's always sunny in Israel?
Most of the time it's pretty sunny. We have like two seasons. One is really long and it's really, really hot. And the other one is shorter and beautiful and not as hot, but still we have a lot of sun. And that's not nothing.
That's the beaches.
We have very nice beaches. We have tropic like areas that are like more green and nice, and forests, wildflowers, mountains. Not all camels and deserts, although we have that too.
Cool. Well, I guess it isn't cool, but it sounds hot. But I will have to visit there sometime. I have a grandmother who recently visited and said that it was her favorite place she's ever been.
Oh, wow. Nice. So come visit. I'll introduce you to my chickens.
There you go. This episode brought to you by the Israel Tourism Board. But you do travel a lot as well. So you were recently in New York. You were at MLConf, the machine learning conference in New York, which I wasn't able to make it to this year, but you were a speaker at MLConf. And Deborah Williams, who's a friend of mine and the acquisitions editor at Pearson that I've worked with for the books that I've created, all the video content I've created, she wrote me a long email summarizing how MLConf had gone. And she said that by far the best speaker, hands down, and not just her opinion, but the opinion of, quote, everyone that she spoke to, was that you, Matar, were by far the best speaker at MLConf. So I was like, well, get her on the show.
So that's very, very flattering. And now, like, take your expectations and lower them. But thank you. Very, very flattering. Thank you. That was a fun conference. There's lots of interesting ideas and good talks. So it was if she said nice. That there was a high bar. So thank you.
And so let's dig into what you do. So you are the VP of Data and Artificial Intelligence at ActiveFence, which is a platform for content moderation, harmful content detection, and threat intelligence. And so to be clear, ActiveFence is not a company that is doing the content moderating. It's not like there's this army of people at ActiveFence that are monitoring for harmful content, but you provide tools, data and AI enhanced tools, that allow your customers to be able to do that content moderation themselves more efficiently. And this seems to be quite a good niche. I could see on Crunchbase that ActiveFence has over $100 million in funding. So yeah, it seems like a very valuable niche to be filling for your customers. So tell us a bit about what this means. How do you use AI to be moderating content? How is that useful for threat intelligence? That kind of thing.
Sure. So ActiveFence, you're right. Like, we are a platform that basically our clients are any company that has user-generated content. So whether it's comments or chats or uploading videos or audio or any place that you have a user that's able to upload content, there's a potential for misuse of that and for uploading malicious content. And our goal, our mission is basically to help platforms ensure that their users are safe, that they have safe online interactions. And so we provide the tools to help them do that. And really this is one of the biggest challenges that face UGCs or platforms with user-generated content, is basically how can they detect this malicious behavior, especially since, as we know, items can be in any format, right? So we need to be able to detect whether it's video, audio, text, images, all of that. And also it can be in any language, and it can also be any number of violations, right? So you have sort of these big ones that, you say absolutely not, like I do not want child pornography, I do not want terror, I do not want white supremacy. But there's like many more. And different companies, different platforms have different levels of sensitivity to it, right? Even something that you can say as blatant as like, I do not want child pornography. No one wants child pornography on their platform. But let's define it, right? What does that mean? Is, baby's first bath? Is that something that we need to be aware of? And so the tools that
Right.
we provide need to be sort of contextually aware of, the policy, the way that things are being used or presented. And so for me, and for all, my teams, it's a super interesting space to be in, because not only are the algorithms that we use really exciting and sort of interesting, but I think the application, right? We're not selling air. Like, we're actually making it like impact it, like making a real impact on like human interactions in a positive way.
Right. So, to what extent can you tell us about those exciting algorithms?
So that's an excellent question. Thank you for asking. Um, so I think that there's many different levels of things that we can do. So the first thing is that we have our a platform, right? And this is a platform that basically enables it enables users or like moderators to come in, to view the content, to look at sort of where it is, and then to make a decision whether or not something should be removed or not. Right? And this is the platform that we provide to our
Mhm.
users. In order to basically ensure that we're able to protect the well-being of the moderators and to make sure they're only seeing things they actually need to be see in order to be more efficient. There's absolutely no need to review everything. There's like most of the things are benign, and even within the things that are harmful, there isn't really any need to view anything. um, then in that case, basically, you want to make sure that you have some sort of automated content moderation on top, and that's where sort
Mm.
of we come in. Uh, yes,
I guess that ends up being important for the mental health of the people who are doing the content moderation as well, because I've read how people in those roles, it can be quite a harrowing experience when you're just watching beheadings and child porn all day.
absolutely,
So,
absolutely.
yeah.
Like moderator well-being is a huge issue. It's in the news, like periodically it comes up as like this huge thing, and ActiveFence is like very concerned about this, right? We deal with data that is not pleasant, right? And so, in the same way that I actively work to protect my data scientists and my engineers from exposure to this, and only when it's really needed, and with a lot of safeguards, we want to make sure that we're all human, and we want to make sure that moderators are also protected in the same way. And so, if there's things that are sort of
Right.
blatant, a beheading, why do they need to watch that? There really isn't a need, right? There's things that are clearly, obviously violations, are clearly, obviously malicious, and should just be removed and banned. And so the algorithms that we use, basically, we use what we call contextual AI. What this means is that we look at sort of the item in the context that it is being used. But also within the item, right? We have our data model basically enables us to take sort of an item, even if it's just an image, and start breaking it apart into the components that it has, so that then we can build those together into a coherent risk score, where this risk score can take into account, what, like, do we see any like weapons? Do we see any known logos? Do we see any known people of interest that we know have, from their history or whatever, we know that they're, spewing hate speech or misinformation and so forth. And then all those components together can combine to basically say, yes, this item is very probable to be risky. Um, and so that's sort of how we build the full picture. And then, of course, there's other layers of that, right? Even, for example, for chats, right? You can say, well, I can just use keywords, right? Like, if I find the N word, then clearly this is very violative. But what if it's someone saying, please don't call me that? Or what if it's a rap song? Or what if it's, someone like, community sort of re-owning a word? And so, like, I'm proud to be a whatever, some slur. And so in those cases, clearly I don't want to ban that. And if I'm just doing keywords, which are sort of contextually unaware, then I lose that ability. And so in those cases, we do need to use sort of language models that are more contextually aware. And these language models need to be trained and tuned on these specific cases, because these are the cases that are always interesting.
That does sound really interesting, and it sounds like the kind of thing that in this brave new world that we have of these really powerful large language models, that this is the kind of thing that they could do really well. That a few years ago, it might have been a lot tougher, um, and so it's great that, that you're presumably able to leverage these kinds of new technologies, especially these kind of multimodal technologies that are emerging. So
Mhm.
I don't think it's available to the public yet, but GPT-4 has this image component where you can have an image, you can provide an image, a photo of your fridge, and ask GPT-4, what can I cook based
Mhm.
on the ingredients that you see in this image?
Mhm.
And so that kind of multimodality, it sounds like it's something that you've been working with for a while.
Yeah, we've been looking a lot at multimodality, because if I'm going back to the child pornography example, because that's for people something that's like so obvious, right? Like you should be able to know whether something is child porn or not. Like we all sort of viscerally know what is bad, and yet sometimes you'll see, a picture of a child and it looks fine, but it's sort of like only the people that are in the know will know that, whether like that's a face of a victim that's known, or in the comments there's links to off platform sites, or something about the angle, or a logo that's just like the picture itself is benign, but there's a logo that's associated with a studio that's been associated with child porn, or the title or the description. And so sometimes it's enough to look at the image. Sometimes it's enough to look at the surroundings, but oftentimes it's the combination. And I mean, in terms of like the generative AI, right now is sort of this sort of like perfect storm for trust and safety, right? Because we're going to be having sort of U.S. elections soon, and so political disinformation is something that's like very, very pertinent, and is now sort of having these large language models sort of lowers the bar for the entry of bad actors, right? Suddenly,
Hmm.
if it used to be
Hmm.
that things could either be like really high quality but low scale, or low quality and easy to catch and high scale, now that's not an issue, right? Um, and so it's like an enabling technology that it's obviously I don't like no fear mongering here. I think it's like has a lot of good that it can do, but we need to be aware of how it can be used and how we can come and be prepared for it.
This episode is brought to you by Posit, the open source data science company. Posit makes the best tools for data scientists who love open source, period, no matter which language they prefer. Posit's popular RStudio IDE and enterprise products like Posit Workbench, Connect, and Package Manager, these all help individuals, teams, and organizations scale R and Python development easily and securely. Produce higher quality analysis faster with great data science tools. Visit posit.co, that's POSIT.co, to learn more. Yeah, no question. So we, famously in the United States in the 2008 election cycle, there were foreign actors involved in creating disinformation in Eastern European kind of farms, and you can imagine, yeah, exactly like you're saying, these kinds of tools like GPT-4 make it a lot easier to create a lot more content because you don't need to have a human typing out everything so much more cheaply. It probably like several orders of magnitude less expensive to be generating malicious content, misleading content, disinformation. So yeah, it is interesting that heading into I mean, I guess we're always heading into an election cycle somewhere,
Yeah,
and so it's something
never ends.
like yeah, it's crazy in the U.S. to me that people in the lower house that they have a 2-year election cycle, and
Exactly.
so like you spend a few months litigating, and then it's back to fundraising.
Exactly.
It's wild.
Yeah. But I think what's interesting is that, like, disinformation is only one aspect of it, right? We're seeing, like, computer generated, or, generative AI generated, child pornography. And then at this point, the question is is it still violative? And I think yes, right? Like, we don't want that stuff out there. Um, I don't care whether something is real or fake. It's still child porn, and
Right.
it
Right.
should be banned. And then there's a second level of like, well, unless I'm trying to find who the victim is, and then I do care. And then there's like another level of detection that needs to be built on top of that.
Is it tricky? I mean, it must be tricky. Something that must add an extra level of complexity to this is that presumably the nefarious actors out there are constantly shifting and trying to evade detection
Right.
by you. So when many of our listeners and myself, when we're building machine learning models, we don't have to worry about somebody trying to outwit the model.
Right.
Like you can build a machine learning classifier to detect images of cats and dogs, and it's not like the cats are like trying to look like dogs and are going to come up with ways of like dressing to look more like dogs.
Totally.
So
Yeah, no, I mean, I think about it in terms of like how is what I do different from car detection, right? Like that's sort of, or cat detection or anything. Or yeah, anyway, there's a million examples. And so I think there's, in addition to the fact that it's evasive and adversarial, right? So there's examples of like QAnon, which is a group that's banned on some platforms, will change their text to be Q, like CUE. And then you have to basically catch it by knowing to look for that. And to know to look for that, that's already subject matter expertise. And that's one thing that at ActiveFence we have. You mentioned threat intelligence. And so we have intelligence analysts that this is what they do, right? They're experts in, misinformation or in hate speech or in terror. And they research these groups. They know about sort of the latest hashtags or trends, like what emojis they're using now, and so forth. And then basically that is able to, they're able to sort of surface data that's relevant. For example, the latest, there's a hate group that was founded in like this last June or this last October, and they're already on different social networks with their logo spewing hate. And so to catch those, to know those, to put, and then those can feed back into our algorithms, and I can know to look for those logos, to look for those phrases, to look for those actors. And so then I'm able to sort of stay on top of it on the fact that yes, it's adversarial. I have the subject matter expertise. It's extremely non-stationary, right? I have new actors coming up all the time, right? If I'm looking for cats and dogs, like how much have they really changed? They're not going to change, right? They're
right,
going to have four legs, a tail,
right.
and ears.
Mhm.
Versus here, the landscape is because it's adversarial, it's extremely non-stationary. And so that's why I need to have my subject matter experts that are constantly feeding me more information of like, oh, this is a new slang term. Oh, this is a new slur, and so forth.
Is there a flywheel that gives ActiveFence a defensible moat between this content moderation and the threat intelligence? So I just kind of had this brainwave here, and you can correct me if I'm thinking about this incorrectly. But so you have the content moderation aspect of the platform. So machine learning models are detecting, hey, we think that this is high risk content over here automatically, and then maybe that automation can assist the threat intelligence part of the company. And then the threat intelligence people, in turn, are keeping tabs on what's going on through a combination of more manual intelligence work as well as this automatically assisted intelligence work that your content moderation side is helping with. And then they can feed back into the content moderation like, hey, like here's something else you need to be able to look for. We need to train a machine learning model to be able to detect this kind of thing. Because yeah, like there's this new logo that you need to be looking out for.
Totally, you nailed it. Yeah, we love flywheels at ActiveFence. We always say like, no strategy deck is complete without a flywheel, and so and so absolutely, it's exactly as you described. So we have our intelligence analysts that are finding things, right? Those feed into the algorithms, make our algorithms better. And then we have incoming data collection, whether the data is like we go out and we proactively collect it, or we get data, clients are sending us data being like, hey, is this violative or not? And then that's basically can then be fed back into the intelligence analysts. So for things that come from clients, sometimes it's things that they haven't seen before that they don't know. Often they do know it. But because we're also out there collecting data proactively, then that's basically able to feed back in. And one core component of this flywheel is something that is it's our proprietary database of sort of violative content. And what this means is that basically we have data that we've already identified, whether it's images or audio or videos or text that we've already identified as being violative of a policy or malicious. We can hash that. And then new content that comes in can be compared to that, right? And then that also helps us, first of all, to be more efficient. But also we can proactively enlarge. We don't need to wait for data to come in, right? We can proactively enlarge this proprietary database by going out there, going to sources that we know are problematic. And that's what our intelligence analysts can help us with. And then next time that it comes in, basically we've already seen it before. And so there's definitely this sort of interaction, this flywheel between the intelligence analysts, the humans, and the AI, one sort of feeding off the other.
Yes. So this is the database of evil that you've talked about publicly before, right? And
Yes.
so, to give a bit of an analogy, this is kind of like how antivirus solutions have a database of known viruses. And then if that line of code that's known to be malicious is come across on your own hardware, that can be compared against this database, and you can say, okay, this is the threat. We need to remove this part of your file system. So similarly, you have this database um, of bad content, of harmful content, and yeah, it's proprietary. Um, so okay, I think that yeah, you have more to
Well,
say about that.
so my the more thing that I have to say about that is only that
Yeah.
to bring us back to the idea that we're in an adversarial space, and if we sort of keep this in mind, it's like we're in the space that's adversarial, that requires subject matter expertise. It's adversarial and evasive, requires subject matter expertise. It's non-stationary. It's multidimensional. And so once we keep those, and it requires context, and once we keep those in mind, then it sort of helps us frame how we want to use this database of evil, but also, or this proprietary database, but also like what it needs to sort of be robust against, right? So if we're in a place that requires subject matter expertise, then sure, then we can keep enlarging our data, like all of our databases, right, with our intelligence analysts. And it's non-stationary, so we need to make sure that it's always updated. Like having a snapshot of this database isn't enough, right? There's going to be new things. But
Mhm.
also, if we're in a place that's inherently adversarial, then we need to make sure that this database is also robust to adversarial manipulations. What does that mean? For example, if I have like a very hateful song, like glorifying the Holocaust, for example, like a love song glorifying the Holocaust, right? These things exist. Um, then, and I know that this is banned on platforms, then I can speed it up, right? And then in the comments or in the title or somewhere, I can say, "Listen to this at half speed." And then now I've basically like made it against all, made it past all kinds of defenses. And so we need to make sure, and the same thing
Mhm.
with images, right? I can like rotate it, I can grayscale it, I can mirror it, I can do all sorts of things. And so I need to make sure that my hashing, any hashing algorithm that I have, is robust to these manipulations up to a point, right? Because it's always this idea of like precision versus recall. Like, do I want to now unfairly capture things that shouldn't be captured, right? And unfairly say that they are violative? Probably not. And so it's a tricky line, but it's that's the line that is in any content moderation algorithm. We're always trying to figure out where the boundary should go.
And I guess that's key to why having a human in the loop in these kinds of decisions so that people can, if they are unfairly forced to remove content, there should be some kind of appeals process in the platform, or yeah, or human reviewer that can make some final decisions. So I guess kind of going back to a point earlier in the conversation, when something is really flagrant and your risk score, which I assume is kind of similar to in machine learning, having a binary classifier where you have a confidence on yeah whether how likely is this to be malicious content,
Totally.
harmful content? Um, and so if that is very high, if you're like, okay, this is 0.99999, we're just like, there's no point in sending this to a human to review. But if it's
Hmm.
0.8 or zero point 0.7, then like there might be something here somebody should review before a decision is made. And yeah, same thing on the flip side when it's yeah, even things that are yeah. So if something does get flagged automatically, because there's still everything is probabilistic in machine learning. So there's going to be cases where uh, the algorithm is very confident, and there's still a and it due to some circumstance you're describing where like a group has reowned something that has been a racial slur historically. There should be the opportunity for that person to say no, like I have like I should be able to yeah. So these
So
there's
yeah.
it kind of works both ways.
So our risk score is exactly as you describe, and like everything is probabilistic, and also it's a business use case where they want it, like how much manual review they want, right? Like maybe for a like a platform for children, they say, you know what, just ban everything. Like, so what if the kids like can't chat about, it's fine. But maybe
Right.
for like other platforms, like a news
Like
platform,
the kids can't chat about racial slurs.
yeah, but fine.
Yeah.
I'm okay with that. Like, I don't care for me.
Yeah.
My kids can just like type 3 words. That's okay. and my kids are anyway. They're getting cell phones when they're 35. Like until then, deal with it. Um, but yeah, so it's exactly that, right? But other platforms would be like, you know what? Even if it's at 99, like for the things that are 99s, like we want to review them because we would rather err on the side of like free speech or whatever. Um,
Mhm.
and so I think that also in terms of appeals, that's a super important point. That's something that is definitely critical in this because this is like, people are posting things and they don't want to be unfairly punished. And actually, right now, I think that the world of trust and safety is having its GDPR moment, right? Like GDPR is for those of you that are not familiar, it was like privacy regulation passed in the EU that ended up having huge sweeping effect because it was basically any time that a citizen of the EU is on an online platform, then GDPR is effective on them in terms of like what cookies and what can be stored and so forth. And you've probably all seen like the notifications on your browsers about privacy regulations. And so now trust and safety is having its GDPR moment with the DSA, which is the Digital Services Act. It's passed by the EU last year. And it basically also puts in protections for trust and safety. It codifies them by law, sort of in a similar way, with fines and so forth. And while it's still new for smaller tech companies, big, like the very big online companies, they have like it's like already being rolling in and they're rolling out, and there's like very strict regulations on them that they need to follow, and it'll trickle down probably to everyone. And so like regulation, fines are on the table, and so these businesses need these tools to be compliant. And part of that is also auditing and understanding. Like part of the DSA is like auditing and understanding why things were banned and explaining it and so forth. And so that's another thing that we invest in is explainability, right? Like if I'm giving a score, then I want to be able to explain why. Like, because a lot of times these things you need that subject matter expertise to understand that, oh, like this particular logo is actually associated with this particular terror group or hate group or child pornography studio or whatever.
Nice. Yeah. So I can see how the evolving regulatory landscape ends up being important, probably helpful to you as you develop these algorithms. We've talked already about harmful content, kind of in static, in in posted content. Um, but there's something that we hear a lot in the news recently. We see increasingly in the news is not just um, content that's been posted, but content that is streaming real time. So there have been incidences in the U.S. recently of shootings being live streamed to social media platforms, and so this happening in real time, that must add an extra layer of complexity to some of the work that you're doing.
Absolutely. There's been like horrific instances of live streaming in the US and elsewhere. And so there's a couple of ways to approach that. One of which is that we can put really, really small content moderation models sort of on the edge device, right? So that does sort of something basic to catch sort of the blatant stuff, and then raise it up for human review. Because I think in these cases of live streams, it's tricky. We're still learning the space, and we would want someone to just like, if we flag it, to take a look at it. Maybe err on the side of flagging too much and then having someone take a look at it. Again, it's a business question of like, what's the platform? What are we looking for? And so have some sort of like detector of, I don't know, gunshots or of something that a small lean model edge device able to flag it right away. We can also do something where we are, once the content makes it to the servers, sample frame. Like there's a question of like, what do you want to moderate? Like every single frame? Do you want to sample every minute, every second? Like at what? There's a huge question. I think what makes this so challenging is just the scale, right? You have like so much data streaming in, and then do the same thing, sample, and then look for maybe more complex things, right? So those are sort of like the typical things, and that's where you're really focusing on the content itself, right? That's coming in. But a lot of these times when you're live streaming something like this, then the perpetrator may have like pre-shared this somewhere. There's people that are joining the stream that are commenting, and now suddenly you have a much richer source of information, right? You can look at who are the other users, who is the user that's streaming, what else have they streamed in the past, what other groups have they been in, what are people writing in the comments, like, and so forth. And suddenly now you might be able to catch it or at least flag it just from the surrounding information, right? Like there's enough indicators of risk from the things that are around it where sure, you want to moderate the content, you want to look at it and so forth. However, you would want to basically look at the other markers of risk around the content itself to make your job easier and faster and more efficient.
Did you know that Anaconda is the world's most popular platform for developing and deploying secure Python solutions faster? Anaconda's solutions enable practitioners and institutions around the world to securely harness the power of open source. And their cloud platform is a place where you can learn and share within the Python community. Master your Python skills with on-demand courses, cloud-hosted notebooks, webinars, and so much more. See why over 35 million users trust Anaconda by heading to superdatascience.com/anaconda. You'll find the page pre-populated with our special code SDS, so you'll get your first 30 days free. Yep, that's 30 days of free Python training at superdatascience.com/anaconda. Gotcha. So it obviously is more complex to be moderating harmful content when you're thinking about it in a real-time situation. But as you point out, having smaller threat detection models on the edge device, so on mobile phones, maybe on laptops, being able to detect these issues in real time and potentially flag those to the social media platform. And then also, once the real-time data is reaching the servers of these platforms, you can be sampling at some appropriate interval in order to be trying to detect whether harmful content, so the sound of gunshots, and then so it can be reviewed as to whether this is like video game gunshots or not, and then something. So probably in a circumstance like that, whether it's real-world gunshots or video game gunshots, we're going to be able to tell more easily because of the contextual information that surrounds that. So the kind of text that people post in response is probably going to be quite different and classifiably different in a video game where there might be more like, well, I don't want to even speculate on what the kinds of things.
Yeah. But I would say that, if we're thinking about it, and like I'm kind of thinking out loud and like refining a bit what I said earlier, is that so you have something on the edge device that does like more basic, like a smaller model that does more basic content moderation, and then instead of it flagging a human, like remember that everything is making it to the cloud, and so we're sampling, and so things that have been flagged by the edge device can then either have like more like different, like more tightly spaced samples, or can have more deeper analysis on it. Like it's basically a funnel, right? And again, it depends what you discover on the edge device. Like maybe you might want to right away flag it to user and be like, listen, like this is not something that is very likely to be in the gray zone. And then also, you can look at the surrounding content. You don't need to wait for the content to be uploaded to the server or anything, right? Like you have the surrounding content. It's like text and who the user is, and like where, do we recognize this user? Where else have they posted before? Where the users that are commenting, like where else are they? And this is where actually like a graphical data model comes in handy, right? Because now you have all these relations between users, and you can see like what have they liked before, what groups are they in, who have they interacted with, and so forth. And then if these are people that are known to us, then we can say, well, actually, like this is a user that if we see them here, it adds to the probability of risk.
All right, so Matar, you've given us a interesting overview of how content moderation works in your automated platform for detecting harmful content. So things like contextual AI, needing to be able to adapt to adversarial opponents, the flywheel between content moderation and threat intelligence that's helpful to you, the database of evil, and how there's flexibility in the way that information is hashed in there so that you can be detecting new variations that are adjacent to existing known harmful content. And then most recently, we just talked about the specific circumstances of real-time streaming and how we can be addressing harmful content in those circumstances. So very interesting. And so I'm curious to what extent you can tell us about the kinds of technologies that you use to make the platform happen. So, what kinds of programming languages? Obviously, we can't get into a level of detail that would allow adversarial actors to be more effective adversarially.
Adversarial actors, listen in now. So
yeah.
and again, I'm giving it with the caveat that like the parts that I deal with are sort of like the data, the MLOps, the engineering, the API. The world of front end is beautiful and mysterious to me. So I can like list technologies that they use there, but they don't mean that much to me. I've always been sort of like a back end geek. And so in terms of stuff that we do, obviously data, people do Python, duh. We also use Node and TypeScript. We serve our models on Kubernetes. We've done a lot of work in house of selecting of like writing stuff to basically select the correct instance type for a given model so that you get the best utilization. We've also are working on like model in versus model out, being like, do we bake the model into the image, or when we spin up the pod, like, do we bring the model from outside, basically in order to maximize or minimize our uptime, because we basically need to be able to deal with really, really high throughput and low latency. And also we don't want to be just like burning money on machines that are out for no reason. And so we have HPA that we then tune, and then we can basically spin up and spin down our machines as we need, and then be smart about which machines we're spinning up. And also, if we're able to sometimes sort of put multiple models on one machine or batch the requests to the machine. And we do all sorts of optimizations to make sure that we're high throughput, low SLA.
Nice. Very interesting. Thank you for being able to go into even that level of detail. So clearly, you have a really deep understanding of not just data science and modeling, but of back-end engineering. So like scaling, being able to meet SLAs, Kubernetes. So super interesting. I didn't know from my research beforehand that you had that kind of expertise as well. So let's dig into your background a little bit to see how this all came about. So you did a neuroscience PhD at UC Berkeley, which is, I think, a great decision. I also did a neuroscience PhD, so for me, that was something that I got into it because I was fascinated as to how chemicals, biology, physics create a conscious experience. And so, like, everything that you think, everything that you do, in some way that we obviously are nowhere near fully elucidating, can be reduced down to physical processes. And so I wanted to dig into that as much as I could. But then as I got started in the PhD, I was like, wow, data set sizes are getting really big. It seems like there's really interesting things that we could be doing there, detecting patterns in data, identifying causal direction in data. And so I went down this road of focusing on programming and machine learning because I knew that whether I stayed in academia or not, those would be transferable skills. And I'm not surprised, I guess, that ended up being true. However, so in your PhD, I know that you were recording activity from surgically implanted electrodes in human brains. And I made this joke before we started recording about how, I felt, I really feel like I made the right choice sticking to silicon experiments or analyzing data as opposed to doing things in, learning how to implant electrodes into a ferret. And I was making this joke about how, people in my cohort in my PhD were doing that kind of thing. But then the exact person that I was thinking of has a really nice job at Google DeepMind. So it seems like you have insight into that. So I ended up getting here.
Where are we going?
A long roundabout way, but we kind of have this. So tell us about your PhD, how that relates to work you're doing today. There's the Insight Data Science Fellowship Program that you use to transition from your PhD, from your academic background into industrial data science. So it'd be interesting to hear about that. And then to finally have it all make sense as to how I started off this entire long transition is that I mentioned how you have a rich understanding of the back end of a software platform. And so just kind of how this all came about, your rich depth of knowledge in the field.
Yes. The first question, let's start with the first one. So my PhD. So yes, my PhD, I was recording recording data from electrodes surgically implanted in human brains. Basically, what I wanted was, animal quality data from humans, right? With animal research, you can stick electrodes where you want, get really beautiful data. You could do in slices. You could do, from train monkeys for years to do a task and then get just beautiful recordings of just like signals for hours and hours of neurons at work. And with humans, you're often limited to things that are either slow, so fMRI, and it's like, you see it many degrees removed. You're actually measuring blood flow. You're not even measuring like direct brain activity. So you're like measuring a side effect of thinking. Or you can do EEG, which is then, electrical signals filtered through the scalp. And even with technologies like MEG and so forth, which is magnetoencephalography, it's not the same. You're not on the brain. And then this really unique opportunity opens up in the laboratory of Dr. Robert Knight at Berkeley, which is basically to work with patients that are undergoing brain surgery, often for epilepsy. So in epilepsy that can't be treated with medicine, right? They keep having recurrent seizures. And so the only solution is to go and to surgically remove the problematic area of the brain. However, before that's done, you need to map out the brain to ensure that, you stop the seizures, but the person is left, aphasic, like they can't speak, or you stop seizures and suddenly they can't, they're blind. And so what you want to do is you want to basically map out the areas of the cortex around the region of interest to ensure that, first of all, you can localize exactly where the seizure is, because remember, until you really get in there, everything is filtered through the scalp and you have like, it's really, you can't tell. And so to figure out like where the focal point is and also what's around it. And so these people, basically what happens is they come in for surgery. They have a craniotomy. The skull is removed. The electrodes are implanted. And then they're bandaged up. And then they're in the hospital for a week with electrodes coming out of their brain, hooked up to an amplifier, a preamp, and then to an amp. And the best case scenario and then their meds are tapered. And there's all kinds of things, many things are done to try to induce a seizure, because the best case scenario is that basically on the first day they have seizures, you localize it, you figure out exactly what's around it, and then like the next day they're in surgery, they remove it and you're done. Oftentimes that's not the case. You need to work to induce the seizure, sleep deprivation, strobe lights, all sorts of things. And so most of the time these people are like sitting in the hospital just kind of like waiting around, right? Watching TV or, whatever. And then we come in and if they consent, then we can come and we can run all sorts of tasks we ensure that the task is matched to the regions of the brain that are mapped, right? There's no point in doing a memory task if, the parts of the brain are only motor and so forth, or a motor task if they're only looking at language regions. And I found this job like very, very meaningful in terms of science outreach, like explain to them the value that they have for science and why I'm doing what I'm doing. And I spent a lot of time just, talking to them about the brain and about my research and so forth. I also found it like emotionally incredibly difficult because you're meeting these people pretty much at the worst time of their lives, right? Like this is just a terrible situation to be in. And so it's challenging, it's rewarding. It's basically, in a way that you don't expect your PhD to be, right? Like you go and you're like, give me data, I'll analyze data. Great. And then there's this. And so I would come in and the task that I was interested in, I was basically interested in sort of tracking the path of a decision in the brain. So I would basically, in the beginning, I just had my one task, but then I realized that basically all tasks that we record are decision tasks. So I dip my foot into like the world of, big data, where I could basically take all the tasks that were run. And any time that there's sort of a decision to be made, then you have sort of like a motor decision, right? Like you see a stimulus, right? So that goes, or you hear something, so that goes into like your visual cortex or through auditory cortex. And then it needs to make it to the decision-making area of the brain, right? To the prefrontal cortex, which is where it sort of moves forward in the brain. You need to make a decision. The decision is made, and then it needs to go back to the motor cortex to execute the decision. And what I want to do is I basically tracked that loop in the brain and was basically able to look at the activity in the prefrontal cortex and basically say, aha, look, like the sustained activity that I see in the prefrontal cortex correlates with, the reaction time, right? I'm able to sort of see when they'll trigger a reaction without looking at the motor cortex. I can see errors. I can see that like the amplitude is also correlated with errors, basically tracking a thought through the brain. And because I was on the brain, I had extremely fast like recordings of what was going on. So it wasn't filtered through anything.
The future of AI shouldn't be just about productivity. An AI agent with the capacity to grow alongside you long-term could become a companion that supports your emotional well-being. Peridot, an AI companion app developed by With Feeling AI, reimagines the way humans interact with AI today. Using their proprietary large language models, Peridot AI agents store your likes and dislikes in a long-term memory system, enabling them to recall important details about you and incorporate those details into dialogue without LLM's typical context window limitations. Explore what the future of human AI interactions could be like this very day by downloading the Peridot app via the Apple App Store or Google Play, or by visiting peridot.ai on the web. That is so fascinating. I really did just sit at a computer and like learn the programming languages and machine learning algorithms, which was interesting. But wow, I mean, yeah, you're really doing real valuable work. And so I think some of that work would go back to like Wilder Penfield.
Yes, so that's when you're actually looking and you're yeah, I mean, that's like the Walter Pepper is like the grandfather of everything that we did. The electrodes that I was using, and again, like things here move really, really fast. And my PhD was a while ago. I'm not dating myself, but it wasn't yesterday. And electrodes have gotten since then smaller. There's also a lot of single unit recordings where you can actually put in an electrode and record from into like smaller populations, right? My electrodes were pretty big and kind of far apart. So I'm recording from larger populations. But yes, it all comes back to like classic neuroscience. And as I was doing it, so that's like the data collection, right? But then you collect the data and it's such a rich data set that like they can sustain you forever. And like the data sets that I collected are still being used for studies because it's like it's like rare data, it's expensive data, it's rich data. You can look at it in many different ways. And so I took my data and data from other studies, and then and as I was working, I said, the brain is amazing, right? There's like I don't think anyone in our field can argue about that. However, what I found myself like drawn to were the algorithms, the machine learning, the statistics, the signal processing, the programming languages, like all of the things that maybe you would say, oh, those are just the methods. I found that those were the parts of the papers that I was reading. Those are like the algorithms. Those were the parts that I was like most drawn to. And so then it was kind of like a natural transition from there to be like, okay, like this is what I'm actually more interested in most of the time. So that was how I found myself there. I did an NLP class towards the end of my PhD, kind of in secret, and then like the rest is history.
Nice, yeah. And then the Insight program. So we've had guests on the past that did this fellowship as well. So it's intended for, I think, primarily people who have already done an academic PhD, have a strong quantitative background, like you did. You're doing tons of, like you say, machine learning kind of data science techniques. So things like time series analysis, dimensionality reduction, clustering, regression, data permutation. So you had all this existing experience, and then so the Insight Data Science program, was that a useful transition after you'd done all that? You'd done the secret NLP course, and yeah, was that still useful for making the transition to industry?
Oh, absolutely. Insight Data Science is wonderful. They what they do is they take people that we already have all of these skills, and we've done data science, and we've done machine learning, and we've done programming, but we're totally clueless about the real world because we're academics, right? We know nothing. Um, and basically, they help us sort of frame what we've done in the context of industry. So, talking about like
Right.
startups and funding and jobs and like what is it like to work, and then also things just like best practices, right? Like version control and things like that, which some people do in their PhD, some people don't do. Like some people's PhD is like 100% in
Right.
like a single Jupyter notebook. Um, and so basically, like they kind of get you up to speed for like and like some like for gaps that you have there, but also just frame what you've done in the context of okay, this is industry. Like here is why what you have is valuable. Here is how you can
Mhm.
use the things that you've done in industry. So they show, people come in, they sort of like hey, look, here's like fraud detection at this company. And you're like, oh, hey, like I've done that. And sort of kind of tie it together for you. Um,
Mhm.
also, like salary negotiate, like all of these like things. And then what you end up doing is they say, okay, in your PhD, you had like 5, 6, 7 years to work on something. Now you have 3 weeks to put together a project that actually brings concrete impact, that like can be impactful, and that you can like pitch it. And then that kind of puts you in the mindset of like, what is a POC? And that also helps employers get around the bias of like, God, I don't want to hire an academic. Like, I'm not gonna get anything done.
Right. And I think there's a lot of relationships between Insight and future employers.
Hmm.
Lots of employers are looking for great data science talent, like the people that are
Hmm.
intaken into the Insight data science program. And so yes, you end up with this flywheel. um,
Ha.
so, and I want to quickly go back before we transition away from what you were doing with your PhD and how you got to what you're doing today. I want to talk a little bit more about. So I mentioned Wilder Penfield and how he was so he was, I guess, the first person to be able to map the human cortex to the level of detail. And I think it was the same situation. It was many decades ago, like the 1950s or something. But same kind of thing: stroke patients, open skull, and so recording from these individual electrodes over the whole brain. And so that gave this map of the whole. So there's this somatosensory homunculus and
Right.
this motor homunculus. So it's this like really cool. I encourage our listeners, and I'll try to remember to include in the show notes a link to some images of this homunculus that it shows you. So I think homunculus is Latin for like little
Little
man.
man. Hmm.
And so it's the idea of this when as you go over the motor cortex or the sensory cortex in the brain, there's this map of your body, and it isn't anatomically correct in terms of scale. So, for example, for both the sensory as well as the motor homunculus, the hands are huge because you have so much detailed sensory perception as well as motor perception in your hands. And I remember like the lips are
The
huge,
lips, the tongue.
but
You
yes,
can do
stuff
you could
like
do
your
a
back is small.
Yeah, exactly. I think we had the same textbook. So one thing you could do is you could take a paper clip, right? And you can like put it together so like its points are like at some distance apart, and you could find like what is the closest distance on your back, basically that you can tell them apart. Because at some point, like you're not sensitive enough on your back to tell them apart, and then you put it on your lips, and immediately you're like, oh wow, these are super far apart, and that basically is reflective of the fact that you have less sensory representation of your back than of your lips in your sensory strip.
Cool. Um, so I wanted to recap on that. Oh, and then yeah, and there's a very specific reason why I brought this back up. Not just because it's really interesting, which I think it is in and of itself, but you were talking about how recording electrodes. So I was thinking about how the recording electrodes that Wilder Penfield would have been working with many decades ago, not many centuries, many decades ago.
Wow.
Uh,
Thousands of years ago.
this podcast will be listened to for millennia. It'll all be confusing. So the recording electrodes would have been much bigger that he was working with than you were working with, and you were talking about how in recent years they've become even smaller. And so
Right.
then that got me thinking about how there is this push with companies like Elon Musk's Neuralink to have brain-computer interfaces eventually that aren't just for people who have serious issues and have their skull opened, but there's this move towards, in our lifetime, potentially having some way of having recording electrodes on our brains without needing to have invasive surgery. And so I don't know if you have any thoughts on that. And I'm going to be asking you after this episode as to whether you happen to know any amazing guests that could dig deep into that
Ooh.
topic area.
Yeah, I have some
Um,
ideas.
oh,
So, so so not all, so actually even today, not all, brain computer interface is super invasive. I mean, it's invasive in the sense that like you have an electrode in the brain, like that's invasive, right? But not for all of them do you need like a craniotomy that opens everything, right? So, for example, you have for Parkinson's patients deep brain stimulation, right, where they basically have a
right.
burr hole. They put in an electrode very specific to the substantia nigra, which is a place in the brainstem where
The block substance.
yeah, there you go. Someone remembers their neuroanatomy, where basically, it produces dopamine, and then when cells there start to die, then you need to basically stimulate it in order to get around the fact that it's not functioning. And so that's just like an electrode that's brought in and that's used to stimulate. And actually, there's like how do you decide how much to stimulate or whatever? There's like a device that you can like calibrate and then decide how much uh, to stimulate. And so that doesn't require a massive craniotomy. That's already like a feedback loop that you have. It's been around for a really long time. You also have things that are more invasive but long term. So the patients that I was discussing, they basically have the electrodes in temporarily, right? They have the craniotomy, the electrodes are put in, wires coming out of the head. Once they have seizures and everything's localized, in the best case, they remove it, skull's back in, electrode's gone. However, there's also different companies, for example, NeuroPace, which they actually permanently implant an electrode strip in the person's brain, and then they're able to basically record ongoing. And the idea is that they're able to predict or give some sort of like leadway before a seizure happens, and then stimulate to stop the seizure. And they record, and then that's uploaded to their servers. And that's also already there. That's like there's patients walking around with it right now. And so I think Elon Musk's is like the next step of that, where it's like, okay, it's not clinical, and let's see how we can get it smaller and smaller and smaller. And if we think about like Moore's law and what he said about things getting like more and more fitting and getting smaller and smaller, I think we'll be there. We'll be there shortly. And then it's a matter of like what like how do you make it minimally invasive? How do you make it so that, because at some point, like in terms of like how long can it be in before cells start to die, before the body starts to reject it? And basically, there's a difference between just recording and versus stimulating, and what does it mean to stimulate, and at what frequency? And I think there's some really, really interesting questions, because already we see. So here's another tangent. We see that brains oscillate, right? So we have like oscillations in the brain, basically where there's different frequency bands that are associated with like different processes, right? So like alpha, which is between 8 to 12 hertz. That's often for like visual cortex, but you have beta, which is like 15 to 30 hertz, and that's for motor movement. Like when you initiate motor movement, you have beta suppression. So there's things like that. But what we also see is that there's individual variability between these frequency bands, right? So like my beta is not your beta, my alpha is not your alpha, my theta is not your theta, and so forth. And so anytime that now we're going to go in and we're going to start stimulating, you're going to say, okay, well, I'm going to stimulate at a particular frequency, but what is that frequency, right? And how do I determine that frequency? And how do I know what frequency is ideal for me versus for you, for whatever the results are? Now, this is like, again, right now it's far away, but there are already like stimulation protocols that we see, even completely non-invasive. Like there's things with TMS, transcranial magnetic stimulation, where people have been experimenting with that. And there's also research about using stimulation for psychiatric disorders, and so forth. So it's a huge, huge field. And hopefully that wasn't too much of a tangent.
No, not at all. I obviously found it super fascinating. And I mean, I think that any of these kinds of discussions around how we can be using technologies to adapt our brains, either to resolve some, some negative issue, like you're saying, from strokes to psychiatric issues, all the way through to potentially having enhancements, which is, I know, like, some of these brain computer interface BCI technologies are designed to, not just be for resolving issues, but also to potentially augment human capabilities in ways that probably we can't predict yet. So I don't know. I think it's super, super interesting. And yes, I will be following up with you to see if you have other recommendations for people who can dig into kind of a BCI episode. So you mentioned, Matar, how your PhD was more intense than some other people's PhDs, neuroscience PhDs, certainly much more intense, than orders of magnitude more intense than my PhD was, in terms of like being really in the real world and dealing with patients. But that wasn't your only intense job that you had. So am I reading this correctly? You were teaching children how to use tanks, preschool tank instructor. No, wait, it's
Yeah.
two separate items. Yeah, so you were a preschool teacher, you were also a tank instructor. So I'm curious as to whether those experiences helped you prepare for your career. And in particular, maybe this might seem tangential, but it wouldn't surprise me if somehow this does tie into an answer, which is that I know that you're passionate about expanding leadership opportunities for women in STEM careers, including data science. And so I wonder if we can somehow tie those two topics together.
Yeah, sure, why
Maybe
not?
not.
My military. In Israel, there's a mandatory military service. I actually did kind of like a strange route. Normally, when you're 18, you basically that's when you start your military service. I actually did
But
my
you went to
undergrad.
Berkeley,
I did.
right? Yeah,
I
you went to Berkeley for an undergrad and then back to Israel to be a tank instructor and then back to Berkeley to do your PhD.
Yes, correct. True story. And
And then now
so
you're back in Israel again.
and now, God, why can't I make a decision? Yes. um, and so I did it a bit backwards, and I actually decided that for my military service, not like there's not a ton of like flexibility in what you do, but like there's some. And I decided that I wanted to try out to do something that was like very different from anything that I would ever do. I said I'm probably going to be in an office for the rest of my life. I want to do something very different, and I also want to do something that's like kind of scary to me that like I'm pretty sure I'll fail at it. I think it'll be really difficult. It's like goes totally completely out of my comfort zone. Um, because I think that's important. And I said, and the risk here isn't that high. Like worst case, like I won't be that great in the military. That's fine. I tried out to be like an instructor. And then specifically, I saw a tank. I was like, that machine is amazing. I want that. And so then I like tried out specifically to be a tank instructor. And the way that it works is at least then was that they have women that basically we train the tank the soldiers. It Where basically in a tank you have the gunner, you have the driver, you have the loader, and you have the commander. And My role was basically to train the gunners, and then also commanders have to do all of them, and officers have to know all of them, and so also training like the commanders and the officers. And specifically for training the gunners, I was trained on the weapon subsystems. So basically, all of the computers and that basically helps them under like all of the computer system within the tank for the weapon subsystem. And it was kind of tricky to do my undergraduate before my military service because I would ask my commanders questions like, "So the algorithm that it uses to understand like what angle to open, is that like does it learn through reinforcement learning?" And they would just look at me and be like, "What? Who are you? Like, what planet did you come from? Like, what are huh?" um, and so that's what I did my military service in. And so it included like it was like incredibly physically difficult because they basically make us go through. Uh, I did basic training, had to do like a million and one push-ups, run around a lot, be outside, not sleep, learn how to basically. I was trained on all of the subsystems of the tank, not only the gunners, basically to learn everything that goes on there, and then focus in on one. Because I only got basically after you do basic training, after you learn everything, that's only after that. Then they're like, okay, now you're going to focus on this. And it basically checked all the boxes of being like really, really hard, incredibly challenging. Turns out physical isn't the tough part. It's like mentally very, very difficult. And so that kind of set me up to being kind of less afraid of failure because it's tough. Um, After that, I was a preschool teacher, which was by far the most difficult job I've ever had. By far, by far, by far.
Oh, really?
Oh yeah.
Wow. I even as you were saying that, I thought you were gonna say like I had this idea of like cuddles and like laughter and like
Oh
how much
yeah.
nicer that would be than a
Yes.
tank than being in a
Tons of
tank and
cuddles,
dumb push-ups.
tons of cuddles, tons of laughter, but like so physically draining. And like so
Whoa.
emotionally, like, I would dream about my kids and like it never leaves you. Like you dream about these kids and you're like thinking about them and like they, And I was also like more sick than I've ever been, like constantly sick. I was like always on like
Right.
some sort of antibiotics. No, but it's like very, very challenging, but it's also, it gives you, it's also another way to do something that's like really tough and gives you a different perspective. And it's both the military and being a preschool teacher are incredibly, incredibly humbling, like very, very humbling. And so I think that's like the biggest takeaway for me of those things that I did. Um, and now, wait, I need to tie it back in to women in STEMs. So uh, now I'm a mom. I have 3 kids. I have a 2-year-old, an almost 5-year-old, in like less than a month, 5-year-old, and an 8-year-old. Uh, and so, first of all, if I'm tying it all into like content moderation, why I do what I do, I think it's like extremely obvious. Like, online harm can turn into offline harm, and I do want to make sort of
Right.
all interactions safer. And in terms of like, I see my daughter and I see the world. She's 8, and the like what it means to be a woman in this world and a leader in this world. And I want to make sure that she has role models so that she isn't the only woman in her computer science class. Been there, so that she has, she isn't the only woman in meetings. Been there. Um, I want to make sure that she has like a much more welcoming environment for whatever she wants to do. And what's really sad to me is that even now, there's like discord. Like I'm hearing from her things like, "Oh, well, boys are better at that than me." No, not true. Very not true. Here's why it's not true. Um, and so these are the kinds of things that like I want to. First of all, I want to make sure that they're not out there online. These kinds of speaking of disinformation, but also I want to make sure that sort of the environment that she's growing up into is much more welcoming.
Nice. Well, it's cool to hear how you are, your passions are coming through across all aspects of your life, and that you're tying together, these personal things, the personal things that you'd like to see in the world with what you're doing professionally with respect to things like disinformation. Um, so we were talking about you being in Israel. Obviously, that's come up a number of times in this episode, in the military service. Another thing that is unique about Israel is that it has very high R&D expenditure per capita. So it is markedly higher than any other nation on the planet. And so that probably creates an interesting flywheel between the strong tech startup ecosystem that there is in Israel. So that helps generate more things that R&D can be spent on. But another interesting piece related to this is that um, I can't remember if this was a podcast conversation that I had in the past. I don't think it was. So I think this is the first time we talked about it on air. But my understanding is that another thing that's fueling tech startups in Israel is this mandatory military service. So you went and did tank instruction, but a lot of people, particularly I suspect a lot of people that already had undergraduate degrees like you did, end up doing things that aren't, they're not training to be on the front lines, and more they're training how to do threat intelligence, they're training how to do signal detection, they're using machine learning and data analysis in the field. And then, so having developed that skill set for several years, when you finish it, you're like, well, what could I do? And one idea that I guess a lot of these people have is, well, I could be making a startup. I could be using these technology skills in industry. So we have these flywheels of I guess there's 2 flywheels here. There's one where the mandatory military training um, creates uh, leads people to be tech entrepreneurs, and then that probably in turn also is helpful for military capabilities in general. And then you have this separate flywheel of R&D, where this strong tech ecosystem is a self-fulfilling prophecy of, oh, great, we should be investing more in this, and so then more people go into that, and yeah. So I've now talked a lot. A lengthy transition. The floor is yours.
So yes, yes, and yes. So yeah, we have mandatory military service. It's currently set at on like in general, roughly speaking, 2 years for women, 3 years for men. Again, with lots and lots of caveats. Um, and there's sort of first of all, there's definitely like a big investment of the military um, in technology, whether it's like signal processing or AI or whatever. And so then you have people that are basically trained in that, like you said, and then they can go out and they have this skill set. And we hire people. Everyone's hiring those sets of people. But even people that aren't going into these sorts of fields, the fact that there's this mandatory military service means that already. From a young age, you're in a place where you're picking up skills that are necessary to succeed in in these companies, right? So for example, leadership skills, right? Like you can go basically in most cases, in order to become an officer in our military, you have to start at the bottom. Like it's not like in the US where you have like West Point and the Naval Academy or whatever, and then that's how you become an officer. Basically, you start when you're 18, and then based on different parameters, you can elect or you can be chosen to do officers training. And so then you have these people that are leaving the military with a skill set of being like very focused and leadership skills and managerial skills and time management skills and all these things that basically saying, oh, that's for a successful entrepreneur or a successful CEO. And so yes, it's one of them is like on the job training, and the other one is just like in general these like other skills they need to have. And another thing that I think is really positive about the fact that it's a sort of mandatory military service is that it's sort of this like equalizing force, right? So everyone goes into the military, almost. Huge caveat, which is like causing right now a lot of social unrest here, but we'll leave that for a different story for a different time. But you go into the military and you're mixed with different people, right? And so that's also a way of like meeting people that you wouldn't necessarily otherwise meet. Then kind of out of your echo chamber, out of your specific place, and then that can also be like a very like an incubator for like new relationships that can then go off and start new companies. And then yes, I think the fact that we have a very, very strong investment in R&D is also, like you said, the self-fulfilling prophecy. Like, what do people want to go end up doing? What do people end up doing is they go to this field, right? It's like that's what we know, that's what we see. That's sort of like that's also a very good way for upward mobility for people.
And so, with our field in particular, with data science, do you think that all of this R&D in Israel will give Israel an edge in AI technology in particular?
Yeah, so yes, absolutely. I think that already we're seeing that. So I have people that I work with. One of which, she used to be like very very senior in the military and in AI. She's I work with her very closely. She's our VPI product, Nurit, and so she was very very senior in the military and building AI infrastructure capabilities. So there's already this sort of cross pollination. We also have people that either, like I said, we hire right out of the military, or in some rare cases, we have people that sort of start doing their studies first before, right? The military says, okay, like you can take this time, we pay for your studies, and then you sign on for a certain amount of time later for the military. And in some cases, we can also hire these people while they're in their studies. And then the skills that they learn with us, they can then go and use in the military. So there is this definite cross pollination that we're seeing, and I think that it also definitely puts AI as like a very very strong and core component of the industry here because it's so useful not only in the military, right, but in general in all of the companies that are going on. And so there's like this very very rich community here of researchers, practitioners, and so forth.
Great answer, crystal clear, and exciting to see what ActiveFence and other AI companies will be doing out of Israel in the coming years and the coming decades. This has been an awesome episode, Matar. So I was promised that you were this extraordinary speaker, and you have proved to be an amazing communicator. It's been a real joy to speak to you.
Thank you.
And so I'm sure our
Likewise.
audience loved this conversation as well. Thank you. And so we covered a lot of interesting topics: automated harmful content detection, neuroscience, military service, preschoolers. I'm sure our listeners will want to hear more from you. So, the first, my penultimate question that I always ask guests is whether you have a book recommendation for our audience.
Of course. This has nothing to do with anything that we talked about, but I really like the book Under the Banner of Heaven. It's by John Krakauer, who wrote Into the Wild. I think
Oh, yeah,
it's
I've read
I
that.
I love reading books about sort of like other other lives or other places. And so Under the Banner of Heaven is a good one.
Nice. Yeah. John Krakauer is an outstanding author based on Into the Wild. So I'm sure that's a great recommendation. He's an annoying person for me when I start typing my name into Google.
Oh, that's true.
He's the one who comes up until I get to the O in my last name. So I'm always reminded of him.
Maybe that's what primed me to think of that book of all books I could have recommended.
There you go. And then my final question for you is, how should people follow you and glean more insights from you after the program?
So I'm on LinkedIn, like everyone. We have a R&D tech blog for ActiveFence. It's engineering.activefence.com. And that's where you can read more about the things that we do and dive into some more details. And please feel free to shoot me an email or reach out to me on LinkedIn. I'm always happy to chat.
Nice. Thank you for making that offer to our listeners, Matar. And thank you so much for being on the program, especially on such short notice. We booked you just days before recording this episode.
Oh, don't say that. It makes it seem like I have no life.
Yeah, right. It just shows, how kind you were to make this time, because you've got 3 kids, you're the VP of Data and AI at a very fast-growing, high-valued company. And so thank you for making the time, despite that, to fit our Super Data Science listeners in.
Happy to.
Nice. Well, yeah, so you mentioned potentially being on the show again in the future, and that sounds great to me. We can hear about how ActiveFence continues to shape this harmful content reduction space in the years to come. Thanks, Matar.
Thank you for having me. This was fascinating and a lot of fun.
I love this conversation today. I hope you did too. In today's episode, Matar filled us in on how an ML model such as a binary classifier can become contextual by taking into account additional context. For example, we can pull out a logo from an image, identify the individual in an image, and compare it with a database. We can examine natural language comments and consider the content poster's history and graph network affiliations. She also talked about how real-time streaming of harmful content presents unique challenges that can be addressed by smaller models on edge devices like phones, sampling on servers, and again, taking into account context. She talked about how we can create a flywheel of defensible commercial AI systems by amassing proprietary data curated by internal experts. And she talked about how she uses Python, Node.js, TypeScript, and Kubernetes for developing ML models, deploying them into production, and scaling them up for ActiveFence's users. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Matar's social media profiles, as well as my own social media profiles at superdatascience.com/683. That's superdatascience.com/683. Your feedback is invaluable, both for spreading the word about this show, as well as helping me shape future episodes more to your liking. So please rate the show on whichever platform you listen to it through, and feel free to converse with me directly through public posts or comments on LinkedIn, Twitter, and YouTube. All right, thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another captivating episode for us today. For enabling that super team to create this free podcast for you, we are deeply grateful to our sponsors, whom I've hand-selected as partners because I expect their products to be genuinely of interest to you. Please consider supporting this show by checking out our sponsors' links, which you can find in the show notes. And if you yourself are interested in sponsoring an episode, you can get the details on how by making your way to johnkrohn.com/podcast. Finally, thanks of course to you for listening. It's because you listen that I'm here. Until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.